Hello everybody, welcome back. Hope everybody had a good fun Christmas. Hope Santa Claus was good to you. Hope everybody survived the new year. Not too much over celebrating. Oh, it's been a long break here. Been snowed in, so I apologize for the delay on these videos. But I've been working on the chassis and getting ready for this next run. We're going to start building this thing. Those of you that I've already sent schematics out to that have requested them, I would like to call your attention to a mistake that I made. It's in the main schematic, the one you're looking at right now. I import these symbols from another file, and I didn't notice that they were wrong. And then I just simply copied and pasted over and made double the bridge. What's wrong about this picture is that it's the bottom set of diodes on both sides. This was from a full wave bridge that actually this center point over here should have been the negative. And I didn't pay attention to that. These diodes on the bottom are in backwards. I have the new schematic drawn up, and from here on out, anybody requesting the schematics, you'll get the corrected schematic. But just make a note, these diodes with the arrows pointing down need to be reversed so that they look like the top ones, where the transformers connect on either side. The AC comes in. This is the negative side, so they should be actually reversed on both legs. Okay. What I'm going to do is I'm going to start from the key and circuit and work forward. The format I'm going to try to go with is I will explain it, point out where I'm going to hook up the wires, show what wires are going to go in, and then to keep it from basically like making you guys watch paint dry while I solder and hook stuff up, I'm going to try to compact as many steps in each one of these videos as I can so that they're not overly long and drawn out. I don't want nobody falling asleep. I know it gets boring just watching, but I'd rather put more information than just a lot of wasted time. So what I will do, I'll explain what I'm going to solder in, what I'm going to hook up, and like I say, I'll be starting from the radio side, working with the input cap, the diodes, and the key and circuit first. The relay will get hooked up, this wire will be put in, and I guess the best thing that I could suggest if you want to keep track of where you're at on the schematic, print this out, go get a highlighter, and as we add the wires and parts, you can highlight over that and it'll tell you where you're at in the circuit. So no wires and stuff, connections will get left out. This is the first time I've ever tried to show a build, so I'm trying to figure out the best way to do this and make it smooth enough flowing that nobody gets lost or gets too confused, and without making it too boring. The first thing I'm going to explain, I have a demonstration circuit build up, show you how the key and circuit and the time delay between when the antenna relay keys and the screen relay keys, and on the unkey how the screen relay unkeys actually first and then the antenna relay unkeys last. It's kind of a trick thing that's done with capacitors, resistors, and diodes. You don't need any sequencer, no special weird stuff. It's all done with caps and resistors. The full schematic of the key and circuit, everything that pertains to the key and circuit's right here. The two 1N40, 148 diodes, the electrolytic that holds the charge, this resistor that determines the length the transistor stays keyed. You can actually vary this resistor instead of changing the capacitor to make it from sideband to AM. I see a lot of the main factory work and boxes and builders seem to just use a capacitor. Resistors are cheaper than caps. So just a simple resistor change can make it go from sideband to AM. Just that simple. What it does, it lengthens the time that the transistor takes to discharge the capacitor, because your discharge path is through the resistor into the base emitter junction and out the emitter. See, the emitter and the cap are tied together on the negative side. So if you raise that resistance, I use 2.2K on a 10 or 20 microfarad cap. If I raise that to like a 4.7K, it'll almost double the unkey time. Just that simple, because it takes longer for the transistor to discharge that cap. Okay, the antenna relay, its delay is built in by a cap. The resistor across it is just there to bleed the cap down and get it ready for the next time you key up. The resistor here allows the cap to charge, but it lets the relay key up instantly. When it unkeys, this cap goes to work and holds the relay closed for just a little bit. Okay, on the screen, it kind of works in reverse. You have a drop-in resistor in series, a diode straight to the cap. The cap is allowed to charge. This pulls the voltage down at this point, keeps the relay from keying until after a few milliseconds. But the diode is there to block the cap from keeping the relay held. So as soon as the main relay unkeys, the screen relay can unkey first, and then this delays the antenna relay from keying for a few milliseconds until the screen relays had time to collapse and disconnect. This is a blow up of the transistor I'm going to use. It's a TIP 3055 or MJE 3055. You won't have to worry about blowing this transistor out, I guarantee it. And they're cheap enough, and instead of using little like 2905s and 2N4401s that can get damaged easily by a spike, this thing will be in there. Hell freezes over. It'll take a lot to knock it out. Okay, the diodes I use are 1N4148. I'll get them over on the paper so you can see them. They're just little switching diodes. This is what rectifies the RF to make a voltage out of it that the transistor can use. Electrolytic cap, 20 microfarad, and a 2.2K quarter watt resistor. Okay, and when I start on this, it'll be done in steps. Step one, we'll build just this part. I've erased the rest of it so that it keeps you from being confused about what you're doing. You can easily see each step. And then step two, then we wire up the delay circuit on the antenna relay and keep working on out. That's the way I think this will work best for you and keep you from getting confused. Okay, I think that's, new schematics are available, so anybody that now requests schematics will get the new added schematics. It's got the schematic of the receive boost circuit. I've added that. That's this little guy right here. That's all the bigger it is. That's a little transistor amplifier. There's a 2N2240 or 2N4401 transistor and all the little parts right there, and that's the black thing here is a relay. This kicks it in and out for receive and transmit. Parts list right there. And then the other schematic that I've drawn up and added to the list of schematics is the screen protection circuit. I've drawn this up, figured this out so that if there's a problem with the high voltage, it automatically puts the unit in standby. In other words, it removes the standby operate voltage so that you can't key up and damage the tube. Plus, if you use a single pole double throw relay for the sensing relay, it'll have an output to a red light on the front panel showing you that there's a problem with the high voltage, kind of an automatic thing. And then the other wire is, if everything's okay, it applies the 24 volts to your standby operate switch and everything works normally. That's added to the stack. Okay, what I'll do now is pause the camera here and I'll get ready and show you the little demonstration of the little keying circuit. And I've got lights on it so you can actually see the delay. I've got it kind of exaggerated on time to where they're slowed down a little more than normal, but at least that way the camera can catch and you can see the action of the relays and how they unkey sequentially. Okay, be back in a minute with the schematic, or with the demonstrator. Okay, alright, we're back. There's the keying circuit I was talking about. This is everything in here, both, or actually all three relays. I'm going to build this unit a little bit different. That's why I'm going to guide you on what step, what's first, what's next, that kind of thing. This circuit will actually have three relays, whereas the tube tester only had two. The advantage that's going to happen here is there's a 3-pole relay for the antenna relay, and that allows 2 extra contacts to switch out like lights, like the receive transmit light, and it allows a switching for the receive boost to kick it out of operation when you're transmitting, that kind of thing. And then of course the screen relay is right here, and this is the main keying relay right here. We have the tip 3055 MJE 3055 transistor, the tab transistor, if you can see that. We have a diode going forward to ground, and a diode coming with the band with a positive end back to the capacitor. These resistors I have jumpered in here just right now are for sideband, just to slow this thing down just a little bit. And I think I can yeah, I've got one just barely in there, so I can show you AM or sideband operation with that. Okay, so I'll show you how this thing works. There's a light here, the green one, and a red LED. This is going to key first, then the green one will come on, and then when I unkey, the green one will actually go out first, and the red one will go out last. Kind of watch for that. I'll do it several times, cycle it through. And now, try to show you just by changing a resistor. So that would be your AM speed. You don't need to add an expensive capacitor. Just a resistor, it's all it takes. Now I take that resistor out. What I have is a 4.7K on this one to actually slow it down more, and a 330 ohm is the resistor I'm throwing in for AM. Now we should be back to sideband. You see the delay. Alright, that's how the keying circuit works. That's how the screen relay gets closed last. I'll explain what these parts are. This is the delay cap for the antenna relay. There's a series resistor here. That's this one, 100 ohms. the cap. The 10K across this cap is just there only to bleed the cap back to 0 during unkey to get it ready for the next key up. And the same thing, I'm pointing to things you can't see, sorry. This bleeder cap's the one I'm talking about. Across the cap. Another bleeder resistor across this cap to bleed it down. That's this one right here. Little 10K resistor. And then a diode. You don't have to use this big a diode. I just tried to use one that you could actually see in the camera. That's a, this just can be a 1004, is all it has to be. And it blocks the charge of the cap coming back to the relay, but it allows the relay to key quickly on unkey by keeping the cap from going back to the relay. When it's charging, the voltage wants to drop across the resistor and go to the cap first. And it takes a little bit for the cap to come up to a voltage to where it'll allow the relay to actually key up. But on unkey, the diode blocks it, lets the relay unkey quickly. And on this, it works in the reverse. Lets the relay key up quickly, and on the unkey, it holds the relay key just for a few milliseconds. Okay, well, I'll pause this video now and I'll bring the chassis up here and we'll get a look at it. Okay, here we are looking at the relay and the antenna connector and the radio connector. Here's our relay. If you was not going to use a receive boost circuit, these two outside contacts get jumpered over with a wire. You can see that. You would just jumper over that. What I'm going to do, I'm going to go ahead and put this receive boost relay circuit right in there like so, and then connect the antenna side and the radio side and get ready. I'm going to leave the power wires unhooked for just right now, but I'll hook them up later on, and that'll be in one of the upcoming series when we hook that up. But just the wiring, what we're doing will be wiring the relay, the wire from the antenna connector and the radio connector to the moving contact of the relay. That's what we'll do, and then when I get that done, I will come back and we'll move on to the next step. Okay, there we are, all wired up. The wire going to the antenna connector and the wire going to the radio connector. Don't know if you can see them in the camera can pick them up, but these little tabs, these are little eyelet ground lugs that I've added to where I'm going to mount my key and circuit and that kind of stuff. And I've even got a couple over here for when the coax comes up from the load connector, or the load cap rather. It'll come down through the chassis and come up. The shield will hook to here, and then the center conductor will hook to the other tab of the relay, and keeping everything real short. One of the things, I didn't show much of the chassis before, and I guess I should have. What you're looking at here, this thing right here, is the bottom side of that little blower. It pulls air from under the chassis and blows air up into the tube box to pressurize it. You should, if at all possible, get these connectors as close as you can to this relay. You don't want these leads long. In other words, you don't want to have to go from the relay with a coax over to your radio connector, and the same with the antenna connector. You want it to be right next to the relay so you don't end up with introduce any SWR into your circuit. This cabinet chassis, let me zoom out here. You can see this. This was made of scrap aluminum. Just something I had I wasn't able to get a cabinet on short notice here, but it's 090 stock, and I've used angle stock that I talked about that you can buy at like Home Depot or Lowe's or somewhere. It's just a 3/4 by 3/4 by 1/8 inch angle aluminum, and same with the chassis plate itself against the end plates, an aluminum angle to tying it together. Screw there, and another angle plate holding the front panel on, and later on I'll put angle pieces in the corners to attach it so that it's hooked up on all four corners square. I'll show you where the fan is mounted, like so. The feed wires, power wires for the fan, is going to go right down through a hole right next to the fan itself. And if I can grab it here, I've got it full apart. Alright, this is kind of a look ahead, but that's the airbox. This will be bolted down with tabs of circuit board material, and I'll just simply solder them on. It'd be just like little feet coming out, and I'll drill down through them and put a bolt, and that'll seal the thing down to the chassis to keep it airtight. If you build it this way and you want to check the squareness so that this thing, the edges are all smooth so it'll fit down on a flat surface, you don't want to be able to see any gaps. If you have gaps, just go to a hardware store or Lowe's somewhere and get the sheet sandpaper. Anything like 80 to maybe 120 grit, somewhere in there, and just lay this down on a flat surface on that sandpaper and just simply rub it. You can lay it on a sheet of aluminum or your table or something, look around the edges. It shouldn't be much more than, you know, maybe less than a 1/64 of an inch gap. The screws should be able to pull it down and tighten it. But we'll get to that in an upcoming video on wiring this up, but thought I'd give you a look. So when you're planning your chassis, you've got your load capacitor and tune. Just some considerations: you want to make sure you've got enough room to mount your pieces. You don't want to build yourself into a corner, so to speak. So I'm kind of telling you this now so you'll have, like I say, a little bit of a look ahead when you're planning your chassis out. Load should go on the bottom. Tune cap should be on the top. That way it's closest to the standoff of the plate choke, and then your blocking cap can come right over to it and hook up to it, so that everything, your lead length, is as short as possible. Alright, so what we're going to do next, I got low battery, so we'll make this the end of this video. Start another one. Before the battery dies. Any questions? Send me an email at radiomedic111yahoo.com. And if you'd like to help out, if you feel these are helping you at all, if I'm giving you good information, there's my PayPal address. It's Honda-CB350@live.com. That's my PayPal address. Feel free to ask questions, and I'll work with anybody one-on-one if you need help. If there's anything I've missed or you don't understand, please ask me, and I'll try to explain it the best that I can. Thank you, and we'll see you in the next video. Bye-bye.